Let us continue with yesterday's lecture. Yesterday I was telling probability of 1 less than or equal to z less than or equal to 2, where z is the standard normal variable. It is given by a of this upper limit 2, a of 2 minus a of this lower limit 1. A of 2, that means at z is equal to 2, if I find the area, suppose you are searching the standard normal distribution table, then it is given z values are against 1, it is given to be AZ, that is the area, it is given to be 0.3413. So therefore, for z is equal to 1, here a of 1, I am writing the value 0.3413. Similarly, against z is equal to 2, it is given to be 0.4772. So therefore, I write against to this a of 2, I am writing 0.4772. So this answer is nothing but probability of z lying between z is equal to 1 and z is equal to 2. So if let us take one more problem. Suppose if I want probability of minus 2 less than or equal to z less than or equal to 3, minus 3, say. In this case, what I am doing is I am trying to convert this to a positive side. That means, observe, this is the area of the normal curve, standard normal curve. This is z is equal to minus 2. This point is z is equal to minus 3. I have to find this area. So in order, it is the same as, in order to find this area, I just cut this portion and I am shifting this area to the right hand side. That means z is equal to 2 is this point, z is equal to 3 is this point. This into marked area is nothing but this shaded area. So therefore, probability of z greater than or equal to minus 2, less than or equal to minus 3 becomes, this minus 2 becomes plus 2. Here observe, z is equal to plus 2. Similarly, this minus 3 it has become z is equal to plus 3. So probability of 2 less than or equal to z less than or equal to 3. Now from the previous examples, you already know that this is nothing but area of this upper limit 3 minus area of this lower limit 2. What is area against the point z is equal to 3? If I search in the table at z is equal to 3, the area of 3 it is given to be 0.4987 minus a of 2 at z is equal to 2, it is given to be 0.4772. So this answer is nothing but this area, that is nothing but the probability of z between minus 2 and minus 3. Let us go to some other example. Now suppose if I want to find probability of z greater than or equal to say 1. That means what? This is the curve. Suppose z is equal to 1 is this point. Z greater than or equal to 1 means this area I am supposed to find. How you are finding this area? You know, total probability is 1. That means this left hand side area is 0.5. This is the point. This is the ordinate z is equal to 0. This left hand side area is 0.5. This right hand side area is also 0.5. So out of this total area, subtract this area. That means right hand side area, I told you it is 0.5 minus this area, this into marked area. That means up to z is equal to 1, that is a of 1. So it means 0.5 minus a of 1. In the z column, if I observe z is equal to 1, against that z is equal to 1, you have the value for a of 1, you have the value 0.3413. So therefore, this is nothing but the probability of z greater than or equal to 1. In other words, whenever there is an inequality like this, probability of z greater than or equal to 1, what I am doing is, you are subtracting from 0.5 first, 0.5 minus a of 1. So a of 1 from the table you can get it. For example, another one example, probability of z greater than or equal to say 2. Then also what I am doing, 0.5 minus a of this value 2. This is what I am doing, right? So 0.5 minus a of 2 at z is equal to 2, the value is 0.4772, right? Suppose if I take up another example, probability of z less than or equal to minus 0.2. That means what? This is the curve. This is, say z is equal to minus 2. This minus 2 I told, isn't it? So probability of z less than or equal to minus 2. Less than or equal to minus 2 means this area. This area. Now what I do, whenever there is a negative value, what I do, I am trying to shift it to right hand side. So therefore cut this tile and paste to the right hand side. So this is z is equal to plus 2. That means I am shifting this area to right hand side. So therefore, this is the area what I have to find. So therefore what has happened, probability of z greater than or, this is z is equal to 2. What is this area? Probability of z greater than or equal to 2. So whenever there is minus sign, what happens? Less than or equal to, that becomes greater than or equal to, this minus 2 becomes plus 2. I repeat, z less than or equal to minus 2 is there. So whenever negative sign is there, that becomes plus 2. This less than or equal to becomes greater than or equal to. So from the previous examples, whenever greater than or equal to this 0.5 right hand side area, 0.5 minus area corresponding to z is equal to 2. That you know it already. Okay, so let us take some more examples in the next class.